Welcome back, SQL enthusiasts, to another installment of our SQL Server Performance series. Today, we are diving into a topic that's all about boosting your database's performance to new heights. In our previous video, we explored the game-changing cluster index to combat those pesky last page insert contentions. If you missed that, I'll put the link for the previous video in the description. You can watch it from there. But today, we are taking it a step further. We will be tackling the notorious page latch underscore EX and page latch underscore SH contentions, those bottlenecks that can slow down your SQL server's performance and frustrate even the most seasoned DBAs. And guess what? We got a potent solution that involves an ingenious twist, adding a non-sequential column as a leading companion to your existing sequential primary key column. Yes, you heard that right. We are about to blend order in most spectacular way to transform your cluster indexes. Get ready to witness the magic as we walk you through the why, the how, and the jaw-dropping results of this strategic move. But before we dive in, if you are new here or haven't subscribed yet, remember to hit that subscribe button and ring the notification bell so you never miss out on our data-packed content. So whether you are a GBA on a mission to optimize, a developer seeking to boost application performance, or just a curious SQL Server DBA, this episode is tailor-made for you. Let's jump right in and explore how non-sequential keys are revolutionizing SQL Server performance. Before getting into the demo, in our earlier video titled SQL Server Performance Series, Converting Primary Key to Non-Cluster Index for Reducing Last Page Insert Contention, we undertook the transformation of the primary key into a non-cluster index from a cluster index, resulting in a marked reduction of last page insert contention. This did not completely solve it, but there was a reduction as far as the page latch EX and page latch SH contention is concerned. The conducted tests yielded impressive outcomes with a cumulative 1,437 executions of the insert stored procedure that completed within a span of 5 minutes, each operation averaging a duration of 20 seconds. Now, within the confines of this new video, our focus shifts towards uncovering another potential remedy. Together, we will delve into the solutions, intricacies, and assess the extent to its augmentative impact on the entire scenario. So what I'm going to do is I'm going to drop the table 1, and then I'm going to recreate it. And if we look at it here, basically what I'm doing is I'm creating 3 columns. Column 1, integer identity 1, 1. So this is the identity column, which is basically a sequential column. The value goes by an increment of 1. And this is the main reason why we are seeing this last page contention, because the value increases sequentially, and this is actually causing the hotspot. Column 2 is varchar 100 and column 3 is integer. So now I haven't created any primary key as far as the table creation is concerned. Now what I'm going to do is I'm going to alter the table 1, add primary key constraint pk underscore column 1. And if you notice here, I've not just added only column 1, I have included column 3 as well. So what I'm basically doing is I'm creating a primary key constraint on column 3 and column 1. Yeah. So now what we'll do is we will start our insert stored procedure from 4 workloads, and then see what is the performance improvement, whether the performance has improved or there is an degradation of the performance when compared to the previous solution. Okay, so we have the SQL log scout running, and I'm going to start this workload. So we have 4 workloads here. All these 4 workloads basically are going to run for 300 seconds, and number of threads that will be used by each workload is close to 100. Yeah, so let's click on start all. So let's give it 5-6 seconds, and then let's click on a new query window here, and then let's look for what is actually running on this database server. So if we see here, what I'm seeing is like there are close to 404 rows, and then I'm able to see that the stored procedure is executing, and it is basically inserting into table one. And again, I'm able to see page latch underscore ex and page latch underscore sh wait type. So what we'll do is like we will let this test complete for 5 minutes, and then what we'll do is like we will look at the cumulative wait type as far as page latch underscore ex and page latch underscore sh, and then we will check if it has taken more time than the previous solution, or it has performed better. Let's go to this SQL test tool, and then if you see here, basically what I'm seeing right now is like the average DB time is close to 21 seconds. Yeah, so let's wait for 5 minutes, and let's see what is the average DB time, and also let's look at the iterations completed, and then let's compare it with the previous run. I will pause the video right now, and then I will resume it back after 5 minutes. Okay, so the tests are completed now, and what I'm able to see is like we are able to the tests were able to execute close to 1,445 iterations within 5 minutes, and the average DB time is 19.8 seconds, close to 20 seconds. So what I understand is like the test that we have done for this particular video, the iterations completed and also the average DB time seems to be same as the test that we have done for the previous video, SQL Server Performance Series, converting primary key to non-cluster index for reducing last page insert contention. So comparably, both these tests exhibited same sort of performance improvement. It is not like it has completely reduced the page latch contention, but what I'm able to see is like it has definitely reduced from the initial video wherein we just had the primary key with cluster index on column one. The video 2 and video 3 basically like the first video as far as the solution is concerned, by changing the primary key constraint to use a non-cluster index, or this particular video where we are using a leading column, which is a non-sequential column, along with the sequential column in the primary key. What I'm seeing is like the performance seems to be a little similar. So now let's head back to SQL Nexus. So SQL Nexus, if we can see here, so this is basically the blocking and resource weight statistics page. In SQL Nexus, what I'm able to see is like page latch seems to be the top weight type here, and if we come down, we are able to see like there are some blockings as well, and this blocking is all the head blockers seems to be waiting on page latch, but what we can see is like page latch seems to be topping the chart. Let's head back to the Power BI report from SQL Nexus, and what I'm able to see is like CPU utilization close to 50% during the workload execution for that 5 minutes. And if we go to this wait and latches, what I'm able to see is like page latch again seems to be close to 63%. We have reduced the page latch wait type, but if you compare to the previous video, what I'm seeing is like converting the primary key to a non-clustered, and then for this video where we are using a non-sequential as a leading column in the primary key, the page latch weight seems to be close to 62 to 63%. So it seems very similar. And now if I go to the Power BI report for costly queries, what I'm able to see is like this particular stored procedure seems to be like topping the list. And if you compare the total CPU and total duration, what I'm able to see is like this particular query is definitely waiting because look at the CPU when compared to total duration, this is very, very less. So that means like this particular query has been waiting on something. Yeah. So let's head back to SSMS and then try executing this query to get the top 5 resource consuming queries. And as we saw in the Power BI report, this particular stored procedure USP underscore insert data seems to be the top one, and wait percentage is 99.59%. So that means like 99.59% of the time this query, this stored procedure was waiting on something. So let's look at this one and see where it was waiting. And if we can see here, this particular query was waiting on three things: page latch ex, page latch underscore sh, and then write lock. Yeah, and page latch seems to be topping the list. Yeah, and what I understand is like uh, this particular query is waiting on page latch. We have reduced the number of the duration as far as this query is concerned was waiting on page latch, but still this doesn't seem like a perfect solution. The query, the query that was running on the original table where you had this primary key with cluster index on an identity column. It took close to 24 to 25 seconds, and now the solution that we have put in, that is by converting the primary key to a non-cluster index and then introducing a leading column into the primary key, the duration has come down from 25 seconds to 20 seconds. Seems to be a good improvement, but we will look at other solutions and then see if we are able to bring in better performance. That's it for this video. Thanks for watching. Have a great day. Jai Hind.